All right, folks, this is the moment you've all been waiting for way too long. Episode 3 of Ouroboreality, where consciousness and metaphysics and cosmology meet. Today we're going to be talking about the flagship theory that I created to try to explain the universe in my own way. This is called quantum aliasing, and it's sort of a central theme for me, so it's going to be a primer for a lot of you guys to understand some of the other concepts we'll be talking about. The first episode we did was about time as an illusion. If you missed that one, go check it out. If you missed spirals and implosion, episode 2, go check that out. Those are also good background for what we're going to be talking about today. But right now, the issue of the day is quantum aliasing. So let's get into it. Quantum aliasing, downsampling reality, with a little picture of what it looks like when you downsample reality. All right. So, wave interference. Wave interference is what happens when multiple perspectives emanate concentric wavefronts from a central point. Just like we are looking out into the world, we are the central points that are being referred to here. This is a consciousness ontology based kind of theory. So, we're talking about how our electromagnetic fields, our perceptual fields, interact with each other. So basically, wavefronts interfere with each other. They create sort of interference patterns that are both constructive and destructive in different spots, as you can see in the picture. It's kind of an interesting pattern. It's the most simple version of it that you're seeing here. In reality, it's really what you see around you. Basically, what happens when multiple perspectives meet is that there is some cancellation, some kind of information gets lost, and there are also things that get added that weren't there originally. We call these artifacts, and that's going to be one of the main terminology points is aliasing artifacts. And I did not make that up, and I did not make up the concept of aliasing as a general concept, but I did come up with a way that it applies to cosmology and consciousness that is new and novel. So, uh, anyways, overall signal quality degrades when two signals meet because the signals become mixed together and like waves in a pond, they kind of gush up against each other, as you can see. And here's another example. On the left, if you are downsampling, this is downsampling error. It's a different kind of error that creates distortion. As you can see, you have the blue wave function is the pure wave function, but because you don't have enough information, you create points of sampling. That's what our consciousness does, and it creates the wrong wave function representation out of it. That's a classic downsampling signal misrepresentation. And reality is defined by these really pesky irrational constants like pi, e, and the golden ratio, which is called phi. And also the vast majority of numbers in number theory to the point where they round to infinity compared to the numbers that we're used to are irrational numbers like that go on forever with no repetition, like pi, for example. Everybody knows that one. It just goes on forever and never repeats. Well, that is not unique. That is quite common. In fact, it's so common that basically that's almost like the only kind of number that actually exists. But we only think in smaller numbers, so we end up with errors, just like on the left. All right. So cognition deals only in the realm of rational number set. So we don't think in terms of infinite numbers because we don't have infinite time to think about these numbers. So we think about 3 apples, 3 oranges, 5 grapefruit, and so we think about that, and we think about 3 quarters of an apple, but we never think about pi apples or e apples. The rational number set is defined as numbers that can be expressed as ratios of whole numbers, and because we only think in this kind of terms, cognition must round irrational values in data sets to the nearest decimal value, and that is defined by our perceptual bandwidth. So, the amount of information we're capable of understanding in our consciousness level kind of determines how closely we can approximate these concepts. So, that results in data loss, compression, and artifacts, as we spoke of earlier. that become byproducts of undersampling. That's like turning a WAV file into an MP3 file. If you're a music geek like I am, you will definitely know that that doesn't preserve the fidelity or the purity of the signal. That's a compromise. That is a loss of information, and that results in artifacts and noise. So here's an example on the left of what sampling looks like. It's like you take points every so often as samples of a continuous signal, which we call analog, smooth and continuous, the real world sound that comes into your microphone, real world sound that comes out of your mouth when you talk, everything like that. That whenever it goes into any kind of electronic digitization or approximation through our sensory apparatus that we have, we get what's called discrete, lossy, sampled, low resolution signal compression. So, to make this even more nerdy and technical, we're going to reference this theorem called Nyquist-Shannon sampling theorem. That basically says the sample rate must be at least twice the bandwidth of the original signal to avoid aliasing. That's basically saying if you don't at least have at least twice the highest frequency that's in the content, if you do a Fourier analysis of your audio or whatever signal you're talking about, if you don't have at least twice that, then you're bound to get error. The fidelity of sampled signal is dependent on the highest frequency content in the signal. And so above that limit, or I should have said below that limit, I think, you'll get an unfaithful representation of the pure original signal, and you'll get artifacts. As you can see on the left, you see the examples of fixed sampling, oversampling, and undersampling. The undersampling there, if you were to connect the dots, you wouldn't get the pure representation. This diagram is a little misleading because they do keep the same shape for the most part, but if you were to just only have those points available and were to try to create that wave, like on the bottom, the undersampled one, you would probably not end up correct. So, noise isolation. Basically, an undersampled frequency is like, if you're an audio tech person, it's like adding a low pass filter, which means that you're basically filtering out high frequency content of your signal. You lose the highs and you keep the lows, and in order to hear the noise that you get from this misrepresentation, like turning a wave into an MP3, you're going to have to place both the original and the sampled file on top of each other, like in your digital audio workstation, for example, and you're going to have to flip the wave function upside down so that you would ideally normally get a full cancellation, but since they are not the exact same signal, you will hear some residual noise. Because usually if you flip a signal and its own self, you will cancel it out. But if you do that with a wave in an MP3, you will be surprised to find some noise at the bottom of it. So consciousness is a lot like signal processing and our current established belief system in the Church of Science does not want to admit that. Doesn't want to talk about consciousness, doesn't want to compare it to anything, because consciousness is a bad word. But we are actually fixed resolution samplers ourselves. We access the source field of infinite resolution, which is basically what the woo-woo or mystics community, whatever you want to insult them as, called the source field. It's really a real thing. It's this continuous manifold, the infinite numbers that exist, the infinite possibility space. We pretty much access it, but we only access a little part of it. So that's called finite sampling. That's called having senses. That's called thinking and seeing only part of the bigger picture. This causes collapse of underlying wave function known in quantum physics as decoherence. That's the actual term, and observer effect is something that we've actually come to the conclusion of in mainstream, which I argue in a non-mainstream fashion that causes particles, because particles are what I consider rendering artifacts. The same noise that we just spoke of, but particles are rendering artifacts of a continuous smooth field manifold. Observer must render reality by calculating coordinate relationships and irrational constants via sequential computation. That's like when you see a ball flying through the air, or when you see anything, or when you think about anything, you are referencing things that have coordinates in space time. You're referencing things that have values that describe them in all their different glory. So we're talking about calculations that have to happen with finite resources. So that is fundamentally limited by finite cognitive bandwidth. So we like to think that we live in a three-dimensional world where we have orthogonal or perpendicular dimensions. They appear real to us, but they are actually limited, and that's why physics now has like an uncountable, unknowable number of dimensions. It's not really that complicated once you realize the dimension is really just things that we consider separate enough to plot on separate axes. The unit right triangle, though, has a hypotenuse of the square root of 2, which is a irrational number that goes on forever, so it cannot be faithfully represented, and so you get aliasing there when rendering it through our cognition. And the unit right triangle has a hypotenuse of square root of 2, so it can't be, it can't look to us actually perpendicular. There must be error, and that error must be on all sides since the perpendicular angles are on all sides. In principle, they're supposed to be right angles, but they're not in our experience. That's why we have space-time curvature. Um, so this rendering error must be isotropic, which means it's equal in all directions because all orthogonal axes are in principle right angles. This tension, I just went over that, goes from undersampling all sides of 3D spacetime. But this rendering error does not happen all at once. It forces itself into vectors into other dimensions, which we see as inside and outside. We see as implosion and expansion, because that's really the only place that it can go is in and out. That's another dimension that we forget. So implosion and expansion accounts for cosmic inflation and potentially dark energy, which is the hidden side of time, the hidden side of expansion, the compression aspect that modern science refuses to look at. Um, so basically, this tension, while isotropic in all directions, must be computed sequentially since we have a computational nervous system. This causes the collapse of the axes to happen one at a time. And because of that, it doesn't happen in concentric rings, but it happens in a logarithmic spiral. And this logarithmic spiral, as I discussed in episode 2, implodes and reaches a limit, which is because of our perceptual bandwidth again. So our inability to render the full implosion also makes it reach a certain point where it has to do something. And so when it does that, when it reaches that threshold of implosion, we get what's called translation of vorticity, because this vortex is going in and out. What's going in, then it must go out. So when it does so, it changes from a certain kind of wave to another. It turns from longitudinal to transverse electromagnetic wave. So it turns from electricity to electromagnetism, and it sort of creates a network of nodes that, following the golden ratio irrationality, they sort of disperse into a field of information that is aperiodic, which accounts for non-local consciousness, superluminal, meaning faster than light information distribution, retrocausality, which means things going backwards in time because they're going faster than the speed of light, and entanglement and higher dimensional information transfer. So all kinds of exotic things that probably you just said, whoa, what the heck is all that? basically all this exotic stuff happens once it hits this threshold and sort of scatters information in this really cool way. So we're just gonna breeze past that. What happens when you get vortices imploding is that depending on how much conscious attention and information is coherent in that system, these vortices achieve different levels of non-destructive charge compression, and the level of coherence and compression that they achieve is proportional to the gravitational force they exert on other objects. Because Earth is such a complex and coherent uh, manifold it's a sphere that has a lot of information on it. That's a very gravitationally significant field. So it causes tension on the axis of 3D space-time, which is why it's curved, which is exactly the definition of gravity according to Einstein. So there you have it. Consciousness, time, and gravity explained with undersampling a continuous field, aka quantum aliasing. One of my contributions to science, hopefully. So I hope you enjoyed that. And we'll be back, meaning I'll be back with another episode sometime soon. Thanks for watching.